So if you look at the first pie chart, we have got different fields like arts, engineers, science, CA, commerce, and other, right? And it says, the figure A here, the headline given is that when they entered in 1997, right? Now what exactly is this, we'll understand later. And then there's one more pie chart here where we have got different fields again: finance, marketing, general management, operations, systems, human resource management, etc. And this is the figure B where it talks about when they left in 1999. Okay, so let's see what it says. 2000 students secured admissions into the 2-year MBA program beginning in 1997. Right, 2000 students secured admissions into a 2-year MBA program which began in 1997. Right, 1997. Figure A given below, I mean not below, actually it's above, right? Figure A that is given here provides the educational background of this batch of students. Okay, so basically the figure here talks about the educational background of this batch of students. How many students? 2000 students. Remember, total 2000 students enrolled for an MBA program in 1997. So what is the educational background? Arts background, engineering, science, CA, commerce, and others. Percentages have been given to us, right? 16, 36, 18, 4, 20, and 6. So for example, if I have to find out how many students who've entered into this MBA program in 97 are from the engineering background, your answer would be 36%. 36% of what? Of 2000, because total is 2000, right? So 36% of 2000, 720 will be the answer. Now continue reading it. It says the same batch of students graduated in 1999. Of course, if they have enrolled for a 2-year program, they will graduate in 1999. So these guys graduated in 1999 and had opted for different specializations. Now here he's talking about different specializations. What is first pie chart is educational background. Second pie chart is about specializations as indicated in the figure B. Right? So these are specializations: finance, marketing, general management, operations, systems, etc. All the students who secured admission in 1997 passed out in 1999. Now this is an important data, right? Do not, just take it easily. This point given here makes a lot of difference, right? He says all the students who secured admission in 1997 passed out in 1999. What does it mean? 2000 is not just the value for the first pie chart, but also for the second pie chart, because all those who enrolled themselves in 1997 have graduated in 1999. There was no failure as such, right? Because for any pie chart, you know that the total value should be known. So here the total value is 2000 for both of them. But then there's one more point given here. It says 20% of engineers and 10% of science plus commerce students were with some work experience before joining MBA program. Okay, all other students were without work experience. So he has brought in one more angle here, guys with experience and without experience, right? Work experience and without work experience. So who all were with work experience? 20% of engineers. 20% of these engineers were with the work experience, and 10% of science and commerce students. 10% of science and commerce students. 10% of science and commerce students. Right? Be careful. 20% of the engineers were the guys with work experience. So it is not 20% from 36%. It is 20% of 36%. You're getting it? Engineers here is 36% share. So when you say 20% of engineers were with work experience, what does it mean? 20% were with work experience and 16% without experience? No. It would mean 20% of 36% were with work experience, and the remaining 80% of 36% were without the work experience. So basically this is like 7.2% and 28.8%. You're able to follow. So you have to be careful when you take these percentages. Similarly, 10% of science and commerce. Now science plus commerce, he says. Look at this. Science plus commerce. 10% of science plus commerce. How much is science? 18%. Commerce, 20%. So 18 plus 20 is 38%. And 10% of that, 10% of 38% is how much? 3.8%. So another 3.8% were with work experience. So you need to be clear with this data, right? How do you analyze this data? Because unless that is clear, you'll not be able to answer the questions. And I think, yes, the other important tool that all of you must have is that calculation ability, right? If you do these calculations on paper, like for example, if you have to find out 3.8% of 2000. So if you start doing this, 3.8% of 2000 is equal to 3.8 by 100 into 2000, then 0, 0 cancel, another 0, 0 cancel, the 0 cancel and make it 38, then 38 into 276. If this is how you are going to arrive at your answers, then you better don't attempt these questions, right? You are not fit for such exams if you do calculations on paper. Okay, you have to be doing these calculations mentally, and that requires a lot of practice. So I think the background is very clear, right? The first pie chart talks about the background of these guys who got enrolled in an MBA program, total 2000. Second pie chart talks about the specialization that they passed out with, they graduated with, right? Again, total is 2000. The key point to be noticed, 20% of engineers were with the work experience and 10% of whatever commerce and science were with also work experience. All others were without the work experience. Now let me present the questions to you all, right? So the first question, remember 2000 is the value. We have to just make sure that total is 2000 for both the pie charts. Total here is 2000. Now look at the first question here. It says 40% of students with work experience is specialized in marketing. 40% of students with work experience specialized in marketing. How many students with specialization in marketing are without work experience? How many students in specialization in marketing are without work experience? So first of all, let us find out what is 40% of the students with work experience. He says 40% of the students with work experience specialized in marketing. Now how many had work experience here? Remember the point, 20% of engineers and 10% of science and commerce graduates, right? So guys with work experience, I mean, you don't have to write this on paper in the exam, but just for the sake of explanation, I'm writing it. 40% of the students with a work experience. So 40% of students with work experience. How much is that? 20% of engineers. 20% of engineers is 36% plus 10% of science and commerce. 10% of science and commerce. How much is science and commerce? 18 and 20, 38%. So total students, I mean, we are not counting work experience. Work experience would be this 20% of 36% plus 10% of 38%. Right? How much is this, by the way? 20% of 36 is 7.2 and this is 3.8. So 7.2 and 3.8 is what? 11%. So 11%. 11% of what? 11% of 2000. 11% of 2000, right? Which is 220. You're getting it? 11% of. Are you able to follow? 20% of engineers, so 7.2% plus 10% of science and commerce, 3.8%, which is sorry, this is 7.2 plus 3.8, right? So 11%. 11% of total value is 2000, right? So 11% of 2000 is 220. That means 220 people have got work experience. You now need to understand that this equals 220. Total people who have got work experience is 220. Now he says 40% of these guys were specialized in marketing. Now just play with numbers. I mean, you don't have to write all these steps here, right? 40% of these guys, 40% of these 220 guys were specialized in marketing, right? So marketing specialization with work experience. How much was that? 40% of 220, which comes out to be 88, right? How many students with specialization in marketing are without work experience? Total, how much is the marketing? This thing? 22%, right? Total marketing is 22%. So how many have totally specialized as marketing, guys? 22% of 2000. Yes or no? This pie chart is also for 2000. So 22% of 2000 has to be taken, which is equal to what? 22% of 2000 will be 440. So I know that the total guys who have specialized as marketing, who are marketing specialists are 440. Out of this, the guys who have got work experience are 88, right? Our calculation here, 220 totally, but 40% of these are in marketing. So total marketing output is 440, of which 88 are with some prior experience. He's asking us to find out the number of students who are specialized in marketing, but without any work experience. So what do you do? Difference of these two values, 440 minus 88. How much will that be? 352. So that's your answer. 352 is your answer. Option A. 352 will be the answer. Remember, do not go by the length of the explanation or the number of steps that have been put on paper. I am explaining this to you, so it's taking longer. When you do it yourself, you have to be very quick. It's all about numbers, right? If you ask me, data interpretation is all about playing with numbers. I mean, you are not supposed to write all these steps. Let me highlight what all should not be written on paper. This 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 should not be written. In my view, I mean, if you actually look at it, nothing should be written on paper. Your answer should be 352, all with mental calculations, right? All with mental calculations. Anyway, let's move to the next one now. All right, here's the next question. Look at the next one. It says, if 50% of engineers specialize in systems, how many non-engineers specialize in systems? Right, 50% of engineers specialized in systems. 50% of engineers, total engineers 36%. So 50% of 36%. How much is 50% of 36%? 18%. So basically it says these are engineers with specialization in systems. Systems with engineers specialization, or engineers with system specialization, right? Whichever way you call. 50% of engineers specialize in systems. So 50% of engineers have specialized in systems. So systems with engineering background students is 18%. 18% of what? 2000. How many non-engineers have specialized in systems? How many non-engineers have specialized in systems? Now, what is the total specialization in systems? 18%. If you look at the second pie chart, the systems total is how much? 18% directly. You will not be writing this on paper, by the way, right? I'm just trying to explain it to you. So the point here is total who have specialized in systems are 18%, 18% of 2000. We know that 50% of engineers have specialized in systems. That also comes out to be 18%. 18% of same 2000. When both these are same, what will be the difference? The difference will be 0. How many non-engineers? Is there any scope of non-engineers? 18% of engineers have gone into systems, which is 360. Total systems department has actually got only 360 people. So how many are with non-engineering background? 0. So your answer should be option B. You're getting it? And there's only one calculation that needs to be done here. What is that calculation? Let me highlight. The only step that needs to be done in this particular question is this one. That 50% of 36%. 18. I mean, you need to do it mentally again. Don't write on paper. This is 18. This anyway is 18. So where is the difference? There's no difference. 0 will be the answer. So this one should take about 10 seconds ideally, right? Here's the next question. Look at this one. It says, what is the difference between the number of students specializing in finance in 1999 and the number of students who had CA or commerce background? Now, that's like a regular question from data interpretation, right? We have to just choose the right values and find out the difference. He's asking us to find out the difference. Difference between what? Difference between number of students specializing in finance in 1999. So how many students have specialized in finance in 1999? 25%. See, do not convert these percentages into absolute values. We will do that later. Just look at the percentages first of all. So how many have specialized in finance in 1999? 25%. And he's asking us to take the difference with number of students who had CA or commerce background. Number of students who had CA or commerce background. So commerce is 20, CA is 4. So CA or commerce background is total 24, right? 20% in commerce, 4% in CA, total is 24%. We have to take the difference of these two. Which two? 25% here and 24% here. How much is the difference? 1%. And that's your answer. 1% of what? All these percentages will be with respect to the same value, 2000. Remember, 2000 is the total value for both the graphs. So any percentage that you come across in this calculation will be applied on 2000 only. So 1% of 2000, 20 would be the answer. Option C. Okay. Again, should not take more than 20 seconds in my view. 20 seconds also is like on a higher side. Okay. So try to be quick. Here's the next question. Look at this one. It says 24% of students of graduating class in 1998. Focus. He's talking about 1998. 24% of students who have graduated in 1998 specialized in finance. Find the percentage increase in the number of students specializing in finance from 1998 to 1999. So that's an interesting one. Percentage increase is a very popular question type, right? What is percentage increase? How do we calculate percentage increase or percentage decrease or percentage change? Final value minus initial value by initial value into 100, right? Just to remind you, percentage increase is equal to the final value minus the initial value upon initial value into 100. Right? This is how we calculate percentage increase. Final minus initial by initial into 100, right? Or new value minus old value by old value into 100. Now here he's asking us to find out the percentage increase in the number of finance specialists from which year to which year? 1998 to 1999. Of course, the data for 1999 is given here, 25%. 25% in 1999, right? In 1999 is 25%. 25% of what? 2000. 25% of 2000. What is the value? So this will become the final value. Our final value will be 25% of 2000. But if you understand, what is the value that should be taken for 1998? This is for 99. But what's the value for 1998? He has given it here, 24% of the students. So how much should it be for 1998? 1998, it will be 24% of the students, right? 24% of the students. 24% of the students. Which students is the question? Where is that value is the question mark here. Remember, if you go back to the introduction slide, which I'm sure you will do, I mean, when you're solving it in the exam, you'll have the data available with you. But if you look at the intro slide, what did it say? It said 2000 students. Let me highlight this. It said 2000 students secured admissions in the 2-year MBA program beginning in 1997. And these guys, you know, will graduate in 1999, right? Those who have secured admission in 97 will graduate in 99, right? They'll graduate in 99. Those who are graduating in 98 would have secured admission in 1996. How many people enrolled in 1996 is the question. Are you able to follow? If you understand now, how many enrolled in 1996? Enrollment in 1996 is equal to what? Is that known to us? No. Can we take the same 2000? No. Is it given that every year there will be 2000 students? No, it's not given anywhere. What is only talked about here is that 2000 people got secured admissions in this program. Maybe in 1996 it was less than 2000, more than 2000, some value. So the point that I'm trying to make is we cannot find out the number of people who have entered this college in 96. If we cannot find that out, we cannot find out how many have graduated in 1998. If we cannot find out how many have graduated in 1998, we cannot find out how many have graduated in finance specialization in 1998. And if we cannot do that, then we'll not get the initial value. And if you don't get the initial value, we'll not be able to solve this question. And to analyze all this, you must take about 5 seconds in the examination. Anybody who spends more than 5 seconds for answering this question has already lost it. You may get 1 mark by marking the answer as cannot be determined, right? The correct answer is cannot be determined, option D. But how much time do you take to, realize that is the question. And when I say 5 seconds, I mean it. It should not take any time. I mean, having solved 3 questions by now, you should know that this is gonna be an incomplete solution. I mean, you cannot do it, right? So option D is the answer. Option D is the answer. The last one here, quickly the last one, see what it says. 30% of engineers. How many are engineers? 36%. So let me just replace with 36% directly. And 40% of commerce students. How many are commerce students? 20%. So 30% of 36%, then because it's all about numbers, right? You just have to pick up the right numbers. So 30% of 36%, 10.8%, 40% of 20%, 8%. Specialized in finance. Specialized in finance, right? How much is this? 30%. For the sake of clarity, I'm writing it here again. 30% of 36%. This will be 10.8%, remember. Plus 20% of, 40% of 20%. Or 20% of 40%, we'll give you the same value. 40% of 20%. How much will this be? 30% of 36%, 10.8. 40% of 20% is 8. 10.8 and 8, 18.8%. So basically he's talking about 18 forget about everything else now. 18.8% students specialized in finance. 18.8% of what? 2000. That should be a no-brainer, right? 2000 is the total value always. Now the remaining students who specialize in finance were science graduates. Remaining students who specialize in finance were science graduates. Understand, what is the total specialization in finance? 25%. We know that total is 25, out of which 18.8 were engineers and commerce. The remaining were science graduates. So science graduates with finance specialization. Science graduates with finance specialization. How much will that be? Total 25%. Remaining. So if you remove 18.8%, you will get the science graduate guys, right? So 25 minus 8.8 is how much? 6.2%, right? 6.2%. So we can say people who are specialized in finance and had a science background were 6.2%. Now look at the question. It says, what percentage of science graduates opted for finance? Now this is an interesting one. This is not like a regular question that we have solved. What percentage of science graduates opted for finance? How many are science graduates? See, we are not converting these to absolute values. It's a waste of time. All I know so far is that the science graduate who had opted for finance is 66.2%. What is the total science graduates population? 18%. Which means in 97, when people took admission, there were 18% science background students, of which 6.2% entered in finance. Yes or no? The breakup of finance was given to us indirectly. 30% of engineers, 40% of commerce, and blah blah. So out of that total 25% who have passed out with finance specialization, 18.8 were engineers and commerce students. The remaining 6.2 were the science graduates. Now all we need to find out is what percentage of science graduates opted for finance. Out of 36, again, actually it is 36, sorry, science is how much? 18%, sorry. Actually it is 18% of 2000, but I'm not worried about that 2000 calculation. My answer would be this. Out of 18% students in science stream, 6.2 opted for finance. So 6.2 by 18 into 100. Strictly speaking, this should be 6.2% of 2000 and this should be 18% of 2000. Yes or no? 6.2% of 2000, 18% of 2000. But only, that would be a stupid move in my view, because 2000 anyway is common in the numerator and denominator. So why do you waste your time? Right? Why do you waste your time in that? So 6.2 by 18 into 100 is the answer. Approximately 33.33%. I mean, the very first reaction should be, this is approximately 33.33%. Why is it so? 6 by 18 is 1 by 3. 6 by 18 is 1 by 3. 1/3 is 33.33. And you should also know that this will be more than 33.33%. The value here will be greater than 33.33%. Why? See, the actual numerator is 6.2. It is more than 6. 6 by 18 is 33.33, right? 6 by 18 is 33.33. The actual numerator is more than 6. If the actual numerator is more, the value will also be more than 33.33. Let's look at the options. Immediately option A gets eliminated. Option D also gets eliminated because cannot be determined is not the answer. Of course, none of this is always a dilemma, right? Out of B and C also, I would eliminate option C. Although option C is more than 33.33, but you know that it cannot be so more that it becomes 38.68. 34.44 sounds okay. But the concern is fifth option, none of this. Again, it all depends on your calculation ability, right? I mean, if you have done enough calculations, you will be able to eliminate option C 38.68 without much of difficulty. Otherwise, you may struggle there as well. But even if you do that, even if you eliminate option C, we are left with two options, option B and option E. Option B which says 34.44 and option E which says none of this. So what do we do? Should we take 34.44 or none of this? If you are ready to take a chance, this looks okay, option B looks okay. If you don't want to take a risk, if you want an exact answer, then do the calculation. What is the calculation? 6.2 by 18 into 100. 6.2 by 18 into 100. But in my view, 6.2 by 18 into 100 would be 34.44. See, it's all about split and merge, right? What I would do, take it as 62 by 18. Don't try to do anything else. 62 by 18. It's like 62 upon 18. I mean, just for the sake of explanation, I'm taking, forget about decimals and zeros and all that, 62 by 18. Now I'll break 62 as, 60 plus 2 by 18. 60 plus 2 by 18. What is 60 by 18? 60 by 18 will be 3.33. Yes or no? 60 by 18 will be 3.33. 2 by 18 is 1 by 9. 1 by 9 is how much? 1 by 9. 1 by 9 will be 0.11. So 3.33 plus 0.11 will be 3.44. And I know that there is 1 0 extra available in the numerator. Remember, we have taken it as 62 by 18 means what? You have only taken care of 1 0. There is one more 0 available, which means one more multiplication with 10 is there. So that 3.44 will become 34.44, and hence option B is the answer. I am not sure how many of you have understood the calculation, the way I have done it, because this is what goes on mentally in my mind when I am doing it. And if I can do it, I am sure even you guys can do that. The only difference is practice. So keep practicing. I mean, see, you can also do this 31 by 9, 2 31s are, 2 9s are, but what all 31s are 9s are? I mean, you can't be wasting your time like this in the exam, right? You should be smart enough. 62 by 18. Or if you don't want to split 62 as 60 plus 2, there are other ways of doing it. Take it as 54 plus 8. So 54 by 18 plus 8 by 18. 54 by 18 is 3 exactly. What is 8 by 18? 8 by 18 will be 4 by 9. And 4 by 9 you all must know is 0.44. All these fractions and all we had discussed in our percentages topic, right? How to convert a fraction to percentage. And this is one of the standard fractions. 8 by 18, which is 4 by 9, is a very, it's one of the standard values that you must remember. So 3 plus 0.44 is 3.44. But you again know that it is not 62 by 18, it is 620 by 18. So 3.44 will become 34.44. So option B is the answer. Right? Option B, 34.44. And I think with this, we are done, right?